Now we are on section A, and in this section we have three case-based question and of 4 markers each. Now let's begin with the first question here. In the first question it says Sheila visited a store near her house and found that the glass jars are arranged one over another, like something like this, like maybe arrangement of glass jars like this. Should be like this. We may figure out as we read the question later. One over the another. On the top jar it is 3, and in the next layer it is 6 in the third layer. So what we can do, we can write the AP here, right? So in the first it is 3, then it is 6. Clearly it is increasing by 3 and 9, and so on, like that up to 18th layer. On the basis of this we have to find answer these questions. So the first question is what? It says write the AP whose terms represent the jars. So clearly, if we keep on adding, like the next one is going to be what? Plus 3, which is 12. And since there are 8th layer, so 8 into 3, that is 24 will be the number of jars in the last. Okay. Now, what we have to obtain is the AP only. I can see AP is there, and we have to find the common difference. So what is common difference? Common difference is 6 minus 3, or you may find 9 minus 6. So this is, say, if I do 6 minus 3, the common difference D, which is 3 here. So we got the AP and the common difference. Now, next question is, they are saying, is it possible to arrange 34 jars in a layer if this pattern continue? So what we are going to do, we are going to take AN as 34 and we'll be finding N. We'll be finding N. If N is a positive integer, then our answer is yes, else no. So I'm going to replace AN with the formula which is A plus N minus 1D. That is equal to 34. A is how much? 3. So replacing A with 3, N minus 1, and replacing D with 3 again. So this is 34. Transposing this 3 to the other side, it will be 34 minus 1, that is 33. And then transposing this to this side, it is coming as 31 by 3. Further, what I can do, I can transpose 3 to the other side. So we are getting N as 34 by 3 and 34 over 3. 34 over 3 in mixed fraction is coming in decimal, or we may write 11 by over 3. So clearly n is not a whole number, right? The number of terms cannot be in fraction or decimal. So we did this. Now what we have to do is we have more parts. That is the third part. Let me make space for the third part. I'll be using this space. Now in the third part, it says if n is the number of rows in a layer, then find the expression for finding the total number of jars in the nth row. So clearly we have to find Sn, and we have to write down the Sn, right? Sn is what? It is n over 2 bracket 2 times A plus n minus 1D. And further it says, hence find Sn, S8. That means we are going to replace n with 8. So this is 8 over 2 bracket 2 times A is 3 plus n is 8 again, 8 minus 1, and D we have obtained 3. So on simplifying, what we are getting, this gets reduced by 4 times. So we have 4 here, 2 into 3 is 6, plus 8 minus 1, 7 into 3. With further simplification, what do we get? This is 21 plus 6. 21 plus 6 is 27, and 27 into 4. 27 into 4, that should give you how much? 108. Right, we got the answer for the third part. This is the third part. Well, this was the first part, and this being the second part. Now, there is an OR option for this, and in this case, it says the shopkeeper added 3 jars on each layer. 3 jars on each layer. How many jars are there in the fifth layer? Okay, so if we keep on adding 3 to this, let's say, if I keep on adding 3 to this, we are going to get a AP again, but it should be different. Like instead of 3, it will be 3 plus 3, 6. Instead of 9, it is 6 plus 3, which is instead of 6, it is 9. This plus 3 is 12. This plus 3 is 15, and so on. So what we can say now that if you have to find, like I'm doing here, the next part. So now this is again an AP where the first term of this AP, we are doing the fourth part here, or third part B, right? Instead of that, it is necessary to write third part B. So we can see that A is clearly 6. That is the first time. D, the common difference, which is 3 here. And we have to find fifth. So fifth is what? A5, which is A plus n minus 1D. That is 5 minus 1, 4D. So A5, replacing A with 6 plus 4 times D, 4 times 3 is 12. So that comes out to be 18. So therefore, we'll say that this is the answer for the fourth B part. The next question is 37. Now you can see that we are given this statement here that there is a very popular shape used. Triangle is a popular shape used in the interior designing. The picture given below shows a cabinet designed by famous interior designer. And here the largest triangle is represented by triangle ABC and the smallest with the triangle DEF. Well, also it's given that D is parallel to, sorry, PQ is parallel to EF, right? Let me magnify this figure. Right. Now what we have to show in the first part, I need more space, should be enough. That's fine. So in the first part, what we have to prove here is that triangle DPQ is parallel to DEF. DPQ, sorry, not parallel, similar. DPQ. What is the triangle DPQ? You can say this is triangle. This is triangle DPQ. You have to prove this triangle similar to the triangle DEF. That is DEF. You need to prove these two triangles as similar. Now, it's very easy to express these two triangles similar. What you can see here, the lines are parallel. So if I show you that the lines being parallel, we are given PQ is parallel to EF. So from corresponding angle property, we can say this angle is equal to this. And likewise, I can say over here that this angle should be equal to this. That's by corresponding angle. So once two angles of a triangle are equal, we can say the triangle similar. So let me write down the triangle. It is DPQ, and the other triangle is triangle DEF. Now over here, as I said that PQ given parallel to EF. So what we can say that the angle DPQ is equal to angle E, and angle DQP is equal to angle F, and they are equal by corresponding angle. So therefore we can say these two triangle, that is triangle DPQ is similar to the triangle DEF, and that is by AA similarity criteria. So we have done the first part here, and now in the second part, we have to show what we have to do. Give that DP is 50. This is 50, and P is 70. So we have to find the ratio of PQ over DE. Now, as you can see that we have proved the triangle similar, so we can write their corresponding sides as proportional. So from here, I can write this is DP over DE. Is it? I made it in the triangle incorrect. Yeah, it's DE is equal to PQ. So what is PQ corresponds to? PQ corresponds to EF. EF. And we have to obtain the ratio of this. That is PQ over EF. From the figure, you can clearly see that the length of DP is 50. So I'll write 50. The length of DE is what? The sum of these two, 50 plus 20, that is 50 plus 70, that is 120, is equal to PQ over EF. So I can reduce and say it's a constant value. So we don't have to further reduce it. We can straight away say that this is a constant here. Now coming to the third part, in this says if twice of AB, all right. So if twice of AB is equal to 5 times DE. Now we are on the other part, right? Let me enclose this. This is the second part, right? Now we are doing the third part. This is what the relation given here. And the triangles ABC similar to DEF. We are given these two triangles. That is, this triangle is given similar to the triangle DEF. These two triangles are given similar. We need to show that their perimeter is a constant. Okay. I think I misread the one of the part, right? This constant was over here, right? We have to find this value. Anyway, we have calculated it correctly. Right, what we have to prove here that the perimeter of these two figures are constant. What we know that the ratio of two similar triangles, since the triangles are similar here, the ratio of perimeter is equal to the ratio of corresponding side. So straight away we can say that the perimeter of the first triangle to the perimeter of the other will be the perimeter of the other triangle. That is, say I took as 2. You may write down the name of the triangle should be equal to the ratio of their side. So I can take the side as AB, and AB corresponds to what? DE. Now check here. This is P1 over P2. From here, if I transpose DE on this side, so let's say if I show it here, I can rewrite this by cross multiplication. This is AB transposing DE to the left. This is DE. Oh, this is, I should show you properly. This is AB over DE is equal to 5 over 2. So I can replace this with 5 over 2. And I can say that this is what we have to do in the third part, right? Which is a constant 5 by 2, which is, say, you may write 2.5, but then it's again a constant. Okay, we have one more part, that is OR part here. So what we have to see in the OR part, so if AM and DN are the medians of triangle ABC and DE, that means we need to draw. So what is median is a line joining the midpoint of a side with its opposite vertex. And likewise, a median over here also. So I may name this median. Let's say if I take as AP, or I can take D, right? And this as, say, P. What we have to prove that, oh, we cannot take that's AM is what? So we have to take M only, and this as N only. We have to prove triangle ABC similar to DEN. So I need to shed the triangle here. The triangle one is ABM, and the other triangle is DEN. All these two triangles we have to prove similar. So what I'll do here, I'll erase the remaining parts as we have already covered these. Now, since these two triangles are similar, right? The triangles here is already mentioned that these two triangles are similar. So we can write their corresponding parts equal. That means over here I can write AB over DE is equal to BC over, like I'm using this triangle, right? So AB corresponds to DE and BC corresponds to EF. Now what I'm doing, I'm multiplying half here, right? So you may do in the next step. I'll do it here only. So if I multiply half, what you see that this turns out to be AB over DE is equal to half of BC is what? I can write BM and half of EN. Reason being, N is the midpoint. It is EN. Moreover, I can write this angle B is equal to angle E as these are corresponding angles of similar triangles. So angle B is equal to angle E. So now we can say that the triangle ABM is similar to the triangle DEN. And the condition is similarity condition is that is two sides and one angle, right? So it's SASP will be the similarity criteria for proving. So this is, yeah, that was third part or part. So this is also done. Well, the last question from this sample paper it says metallic silos are used by farmers for storing grain. Farmer Girdhar has decided to build a new metallic silos to store a harvested grains, and it is in the shape of a cylinder mounted by a cone, and the dimensions of the silos are given here. So let's first draw the figure. So what I'm going to do is first I'm going to make a cylinder and a cone above it. Say this being the base of the cylinder. Bases, right? And as you can see, they have same base. Now, if I see the dimensions given here, the dimension that is the radius, here the radius of this, radius of the base is 5. So we can write R as 5 here. R is equal to 5. And the height, what is the height? Height is 2 meter. Where from I wrote this is 1.5 meter. And the height is 2 meter. The dimension, okay, fine. This is the conical part, right? For the conical part. So height is what? The height of is this. And this height of the cylindrical portion, I'm using, say, H to denote it. And this is how much? 2 meter. Further, these are the dimension for the cylindrical portion. Well, radius of the base is same, 1.5. And the height here, so this height, I'm using capital H to denote it, this height. So I'll write capital H is equal to 7 meter. Now we are going to use these informations to answer these questions here. So what is the first part here? The first part is to calculate the slant height of the cone. So slant height of the conical part. So we know that this is the slant height. And this is calculated using we have a relation between L, R and H. So L square is equal to R square plus H square. So this is L square. R is how much? 1.5. So it should be 1.5 square. And H is 2. So it is 2 square. So further L square 1.5. 15 square is 25. So it should be 2.25. 2 square is 4. So L square is 6.25. We know that under root 625 is 25, so it should be 2.5 meter. So we got the answer for the first part here. Now in the next part, we have to find the curved surface area of the conical part, that is CSA of cone, and CSA of a cone is what? Pi RL. So replacing pi, the value is not mentioned, so we'll be taking 22 upon 7. Radius, as it is 1.5, 15 by 2 is also fine. 15 by 10, right? 15 over 10. And the height, which is 2.5, I can write 25 over 10. So if I reduce it, there is no point, by reducing this, I can reduce 5 times, 5 2 times, 2 1 times, 2 11 times. So what we'll get here, 15 into 5, that is 75, and 75 multiplied by 11 should give you 82.825, and that divided by 825. 825 divided by, this is how much? 70 below. Okay, it can be reduced further. Let's divide it. If I divide directly, I'll get 11.78. So this is equal to 11.78. So this is the answer for the second part. Now coming to the next part, what we have to find out is the find the cost of using the metal ship to make the cylindrical part, and the rate is given as 2000 per meter square. So the cylindrical part, they are saying that, and we are not mentioned whether it's a closed or open. It has to be closed from below, right? It has to be closed from below. But then they are just asking the cylindrical part. So in that case, we will be finding the curved surface area only. So what do we know the curved surface area? Let's make some space over here. So curved surface area of cone cylinder, right? So CSA of cylinder is 2 pi RH. It is 2 pi RH. And if I replace this value pi as 22 over 7, radius as it is, I can write it was 15 over. This is 15 by 10, which is 3 by 2. And height is 7. Well, here this get cancelled. So I can reduce 7 with 7, 2 with 2. So we are getting this as 66 meter square. So 66 meter square. And in order to get cost, we'll have to multiply with the rate. So 66 multiplied by 2000. So that will give you 132,000. In rupees, that will be the cost here. This is in rupees. We did it, and now we have to find the total capacity of one silos. That means we have to find the volume here. All right, so since we have to find the total capacity, we'll be finding the volume of this whole thing. So I will erase the previous part and I'm going to work on the volume. So to find the volume, it is the combined volume, right? For the third part, the required volume will be the volume of cylinder, which is pi r square h, plus volume of the cone, which is 1 over 3 pi r square h. And we have different h here, so I'll be using this as capital H and this is small h. As for the figure, we can see pi is common and r is same, right? So I can take r square as common. This is small h. Was it small? No, it's capital H plus 1 over 3 times small h. So let's plug in the value. Pi is 22 upon 7 r square. As I said, r is actually 3 by 2 here. So I'll be writing 3 by 2 into. This will minimize the calculation. Times h, which is h is 7 plus 1/3 of h, that is h is 2 here, right? So it's 2 by 3. I can straight away write 2 by 3. Now for further simplification, these two can be cancelled. So what we are getting here as V is equal to, this is 9 multiplied by 11, that is 99 over 14. And this if I solve, 7 threes are 21. 21 plus 2 is 23 divided by 3. Well, a part of it can be reduced. I can reduce 3 one times and 3 33 times. So if I multiply 33 with 23, whatever it comes, that divided by 14. So that should give you the volume of this. So I can say that after final calculation, this is, if I multiply 33 with 23, it's coming 759 over 14. And to get the answer in decimal, if I divide it by 14, I should get at 54.21 centimeter cube. Oh, it's meter, so it should be meter cube. So this would be the answer for the B part.